going to get started because there's going to be a mob of people that are going to come in at any moment. You guys hang on to your seats. It's going to get ugly. So we're not brothers, contrary to popular belief. We're both Erik. We spell our names the same way. You guys, most of you know us. I'm the head of sales in the U.S. and Erik, you're the global sales manager.
One of them. 14
years with Elos. Guy knows where all the bodies are buried. He knows everything. So if you ever have any questions about Elos, this is your guy right here. I've been here 2 years, but I've been in the industry for about 25. A lot of surgical experience, implant side of it. Go ahead, Erik.
Yeah, maybe before we get started, we know you, we know what you do, so we can tailor it so it fits for you. Your lab, or
yeah, GPS Digital Dental Lab. We're based out of Orlando,
Florida.
Right.
Okay. Okay. Welcome.
Lab owner from India.
Okay. Do you work in lab?
Yeah.
Okay. We got all lab people here.
Okay. Cool. Cool. Yeah. So basically, what we have on the agenda today, I think the title is "Embracing a Validated Workflow," and we're going to talk a little bit about digital implant dentistry, which is kind of the reason that that you start talking about validations and so on. Why is it important, and what is the digital dentistry workflow that is part of what you'll see is a kind of a validated workflow that will make life easier for you as a lab if you want to make your own prosthetic components and still be FDA compliant.
In order for us to understand where we're going, we have to look back at where we came from. That's what this slide is about, and this is what the day used to consist of back in the 90s. And some of you, I don't know, you seem probably too young to have been around then. I don't think that you were working in offices, but back then, as a lab tech, sometimes you'd be expected to go out there and take impressions and help people restore their cases. And this is what we used to do. And back then, you didn't have to have a validated workflow because you did checks constantly. You were constantly reviewing your process. You were constantly updating, and it was really a live case. So there was no way for the FDA really to set up any type of controls like they have now. And you know, there were issues back then. You know, what were the issues? Inefficiencies. It took a lot of time to do this. There would be air bubbles in the impression sometimes. The patients wouldn't sit still. This is a lot of stuff that would go in there. If you had a gagger, I mean, there were so many things that you had to go through. Well, it wasn't predictable workflow, but it was definitely art. And that's what we did to get us to where we're at today. Here's another picture of back in the day when you would dream of getting a big account, but nightmares are dreams too, because sometimes you'd get a big account and then you had to deal with all the headaches of having a big, large account, getting up at 4 a.m. to help them with surgery sometimes. We've come a long ways. I have a degree in marketing, a degree in business, and I'm a dental geek. Okay, we'll tell you that I'm a geek, but I'm also a nerd when it comes to demographics. And so I don't know if you guys have access to the iData studies that come out. They do a report, I think, every year, but very expensive. They're $2,000+ to get these reports, but the reports are great because it shows you, and this right here is a 10-year final abutment market from where we were in 2020. Oh no, this is a 7-year review. From 2020 to 2027, this is what the market looks like. So if you look at the first pie chart, that's the CAD/CAM in 2020, that light blue. And if you come over to 2027, this is where we're expected to be. So the market is definitely picking up and it's growing rapidly. So this right here this is a 10-year review. To quote a good friend of mine, he doesn't even remember saying this, but the first time I met you, you did a presentation at Lab Day West, and you had a quote that has always stuck with me, and it said, "A predictable workflow creates a predictable cash flow. That's what's great about digital. With digital, you know, you can predict what next month's going to be like. And so this right here is this particular infographic that you see here. It shows you a full 10 years from 2017 to 2027 and how we're trending. You see the light blue is actual growth. The digital market is really, really growing exponentially, and you know, the future looks pretty good for us. It does in this part of the market. We're growing faster than the dental implant market is. It's growing around 6 to 7%. We're growing around 10 to 12%. So we're in the right room. Now, this is something that's interesting here. That was in, this is now. The industry has shifted. Who places the implants is shifting rapidly, which means your workflow is going to change also. If you look at something I find really interesting with this chart is the number of GPs in the USA that are placing implants from 2017 to 2027. Okay, it goes up a bit. You go up from 149,000 to about 165. Now the percentage of implants that are being placed per year is going up also. But what I find interesting is the training that's required. You need a residency if you were an oral surgeon. Those guys started placing implants. When I started, it was all oral surgeons and periodontists that were placing implants. And it started changing. The market started changing. More and more GPs. They went to a 4-year residency. To become an implant doctor that places implants, you can learn that in 2 days now. Now, is that enough time to learn? I don't know. I don't think so. You know, do you need 4 years? Maybe not. That might be too much. But that's creating a lot of these issues because the implant wars, the way we look at them right now, we look at the implant companies. Like Straumann is fighting for business share from Nobel and vice versa. Really, the implant war is being fought in the trenches. It's who's placing the implants. And that changes your workflow because now the GPs are placing implants. They don't know how to graft sometimes. They're not comfortable grafting. So you're going to have implants placed in more and more odd sites. It's going to create more work for you. If you look at this, which is very interesting to me, the number of specialists in America is only going to go up 2,000 over that 10-year period. But the numbers of GPs that are placing implants is it's insane. So, you know, you guys are in a good spot because digital kind of gives you a bailout. Did you have a question? I can tell that you do, because this is pretty casual. We can go if anybody has any questions. So this is something to think about.
Okay, so what we will look into is this embracing a validated workflow. In order to get started on that, so we need to look back and say, what is digital implant dentistry basically? Well, it started maybe let's say 10, 15 years ago when you started to have scanners that could actually pick up implant positions in a good enough quality that allow you to digitize that part of the process. Initially you would take impressions, you would scan the impressions. Nowadays you can scan it with an intraoral scanner, so your whole workflow is digital from the very start. You have some software that will allow you to manipulate all the data to create your restorations where you would sit and do wax up previously. Now you can do it all digitally on a computer screen. Let's go on. From there, you need somehow to connect that to something more tangible. You need to connect it to equipment that can make your restoration, whether it's a milling machine or a 3D printer. And if we enhance even more in digital dentistry, you can make prosthetic driven guided surgery where you actually, based on the restoration you want to create, can go back and find out. So whether I want to place the implant, whether it's like a freehand placement, this is the X-guide, or if you mill or 3D print a surgical guide for setting the implant. All of this comprise digital implant dentistry, so to speak. And it's becoming very industrial, and that's the reason we start looking at validation. It's basically because of FDA that we begin to look at validation. Previously, when you were waxing and grinding by hand, it was sort of difficult to control and to set up measures for inspection and so on. So it was not really easy to make guidelines from FDA on how you should do. So traditionally, most lab work were exempt, but as we get more and more digital, and you can go to the next one, as we get more and more digital, the manufacturing process starts more and more to look like industrial production, and all of a sudden you have some process flows that you can control, and that's the reason that FDA is now looking at this manufacturing as an industrial process, and that has led to a change in the guidance. So today and for a couple of years, there has been clear guidelines from FDA in relation to CAD/CAM abutments. CAD/CAM abutments is, well, either a tie base or a custom abutment. It falls under the category of CAD/CAM, and the way FDA handles this, they have what they call product codes, and for CAD/CAM abutments, they use a product code called NHA. It's not an abbreviation for anything. It's just the number the letters they pick for that. So that's the product code they use for prosthetics in relation to dental implants. And with that product code, FDA has set up a pretty firm guidance. You can that require the manufacturing to be done at a validated milling center. I think we will just go to this one. So there's a guidance document from FDA on these CAD/CAM abutments. They say, okay, if you are under this NHA product code for your tie base or your custom abutment, then you have to include this statement in your indication for use. All digitally designed abutments and/or copings, in this case, we took an example with BioHorizons. They are intended to be sent to a BioHorizons validated milling center for manufacture. This means that if you have a tie base that is FDA cleared under this number, you can in principle not make the restoration in your own lab unless you have been validated by BioHorizons to be a milling center for them. In order to be a validated milling center, you have to have a site registration with FDA, and that's first of all an investment of $6,000 plus per year. You will open up your doors for FDA and invite them in to come and see what you're doing, and you need to have a quality management system on top of that. So it put a lot of requirements on you, and well, we know that today probably not all labs know about this and follow this, so they may be violating the indication for use by actually buying this tie base and manufacturing in-house without being a validated milling center. That's of course a risk, and potentially if FDA comes by and see that you're doing it, they can shut you down because you're not acting according to the label of the product. Um,
And it's not just BioHorizons. It's
no, it's
all implant coverage. It's just an example here.
It's everyone.
I don't want to pick on BioHorizons.
So this is from the FDA database. What does it look like for these BioHorizon CAD/CAM abutments? It says here, has to go to a validated milling center.
You got it.
And it's not BioHorizon's issue, basically. They sell it with an instruction for use. Yep. So it's your responsibility to read that instruction for use and make sure that you are a validated milling center if you process it. So, so what if there was an alternative to that? And actually there is, that will make life a little easier. Recently, FDA have opened up for a different kind of 510K clearance that is based on a different product code that is called PNP. And this approach take away this requirement for being a validated milling center. You still have a guidance document that tells you what you can do and what you cannot do, but it definitely makes life much more easy. So the product code PNP, and I don't think you necessarily have to memorize what it says here, but in reality it says if it's computer-aided manufacturing, like milling, 3D printing, or whatever, that's part of the workflow, then you can actually design a digital workflow process that will remove the requirement for being a validated milling center. So if you follow the digital workflow that's described in a given 510K, then you're actually good to go without having to sign up to be a medical device manufacturer, pay the fee, open your doors for FDA. So how does it work? Elos has made a number of these 510Ks today. We have one for our hybrid base, which is the name we use for our tie bases. Maybe you remember from the BioHorizon version, it said has to go to a validated milling center. If you go to the next one, we will. What it says here is the zirconia superstructure for use with the Elos hybrid base are only intended to be designed and manufactured according to digital dentistry workflow. No mentioning of a validated milling center. So if you adhere to this digital dentistry workflow that is described in the 510K, then you're good. Then you don't have to register. And this means that we have actually taken the burden of validating a specific workflow, and we do the same for the custom abutment, which is a pre-milled blank that allows you to mill a custom abutment. Same wording are to be designed and manufactured according to a digital dentistry workflow. No mentioning of a validated milling center in this one either. Yeah. So what is it that we actually do? Well, we remove the validated milling center and only look at equipments and components and materials. You take the next one. In the workflow, we have defined there's a scanning, there's a CAD design, there's some CAD export. Whatever you design will be exported in a digital format, normally through some CAM software that will turn your design into information that your milling machine can mill from. And then there's some equipment and some materials included in this. Yep. So the first step is, of course, the scanner and the scan body. And clearly, for this to work with a good quality, you have to make sure that you use a scanner with high precision. That is already validated by Elos in the 510K. We have defined what kind of scanners can you use for this validated workflow. And then, of course, you need to have a scan body that has high precision, as a component manufacturer in this field.
Sorry.
So just go back.
There you go.
As a component manufacturer in this field, we have long experience in making really high-end, precise scan bodies and other components. The one we have today is based on a peak scannable top. There's a tiny hole for the screw axis.
Do you want to go back?
Yeah.
Okay.
Just a sec. Tiny hole for the screw axis that really have allowed us to maximize the surface area of the scan body. The more surface area you have, the more precision you will get in your scan, basically. So there's a lot of thought going into this design. The screw is retained inside; it will not drop out when you use a scan body, whether in a lab or if your doctor use it in the clinic. It's perfectly sealed inside. Okay. As a sort of testament for the quality of the scan body, we can say that the scan body from Elos that is distributed by Nowak is actually also included in official libraries from Nobel Biocare, from Dentsply, from NEOS, BioHorizons, even Medentika, which you would argue is probably sort of a competitor to Elos, offering the same kind of solution. They even adopted our scan body and put in their library, and Straumann also. So you need to have quality products in what you do to make quality restorations. For the CAD software and library, just
go ahead.
The software is not exempt from a 510K, so that has to have a 510K number. But both 3Shape and Exocad have now managed to get an FDA approval for their abutment designer in US. So these two have their own 510K number and are cleared for doing abutments in US. You have to have a library that goes into these softwares as well, and that library, by dictate from FDA, can only hold components that are approved by FDA. So all the components inside the library has to have their own 510K number, and in this validated workflow, obviously the parts that will be in the 510K from Elos that allow you to mill locally, all of those parts are in the library that you can import. The different components that are in such a library. First of all, the scan body, which is the starting point to make sure that you can capture implant position. There'll be a model analog if you are 3D printing a model and want to check your restoration on a model. Maybe nowadays there's a tendency that some of the cases can be done model-less, but nevertheless, if you 3D print a model and need an analog for that, it's in the library and it's cleared by FDA. Same goes for the titanium base or the premill blank that will allow you to make a custom abutment. It's all aligned perfectly in the library, and libraries are also a thing to be serious about. There's a lot of different libraries out there. You have to make sure that, first of all, they are cleared by 3Shape or Exocad so you can install them, and you have to make sure that it's good quality of libraries, and also sort of a testament of the quality of the libraries we're doing. We actually also make libraries for the implant company as a service, so we are really on the forefront with this. Then we come to the CAM software. That's where you manipulate the design and turn it into a set of commands that can be interpreted by your milling machine or your 3D printer. That software is not a medical device, and it doesn't have to have a 510K number. But in our 510K, we have validated the CAM software that you can use. So it's a requirement that you use a CAM software that is within our 510K for this, to allow you to do this in your own lab. Right, next one. Then the milling machine, sort of the same issue. A milling machine is not a medical device, so it doesn't have a clearance from FDA, and this means we will have to validate the milling machines that goes into to a validated workflow. We are doing that. We have started up in our let's say first version of the 510K. We will have an IMSI core. We will very soon be adding VHF and Roland. So you will have like a la carte menu where you can choose what scanner you will use. Will you use Exocad or 3Shape? Will you use one milling machine or another milling machine? All covered by this 510K PNP version. Materials for the tie base. I don't know if you caught that or if I even mentioned it, but for the tie base we have to specify both cement and restoration material, being zirconia, because these products are also medical devices per se and needs to have a 510K number. So you will have to choose from whatever, again, what we have put in the 510K. But once you choose within that range, then you're free again to produce this in your own lab.
There you go.
So, how to get started with this? Basically, I think the key message is we have already taken care of the 510K clearance. You don't have to file with the FDA. You don't have to register as a contract manufacturer or medical device manufacturer with FDA. If you follow the equipment in the 510K, you're good to go. And your distributor will be able to help you with this. And I do believe that Nowak have all the Elos components that are part of this, and they even distribute milling machines. So you would be...
You have everything needed, right?
Good to go.
Yep.
Yeah.
That's
awesome. Final comment is, ideally you should have a quality management system.
Yeah.
And I mean, not only for doing this, if you're a serious dental lab, you should have a quality management system to make sure that whatever you produce is of a consistent quality and you have some traceability in what you're doing. Who did what? Did we fire the sintering oven at the right temperature? All of that, preventive maintenance, whatever goes into having a quality management system, it's a good thing to have. It will definitely improve your quality. That's what we had for you today. Feel free to ask questions if there are any.